An angle is two rays with a common endpoint. The common endpoint is referred to as the vertex. The two rays are referred to as the legs, or the two sides of the angle are referred to as the legs. When you are denoting an angle, the vertex is always the middle letter. So for example, in this big angle here, we would denote that angle MNP, where N is the middle letter, or PNM with an angle symbol before it. The smaller angles are denoted angle MNO or angle ONM. Either order is fine as long as N is our middle number showing that it is the vertex. Our other small angle is denoted similarly. We cannot use angle N to denote any of these angles because it would be unclear which angle we are referring to. If all we had was one angle like this one above that is not split into smaller angles, we could use the letter of the vertex to name it, and we'll see examples. There are 6 types of angles. An acute angle is between 0 and 90 degrees. Right angle is exactly 90 degrees. An obtuse angle is between 90 and 180. A straight angle is exactly 180 degrees, so you can think of it as a straight line, is 180 degrees. Our reflex angle is actually this blue angle down here. Up here we see an obtuse angle, but the blue angle that's denoted is the reflex angle is between 180 and 360, so between a straight line and a full circle. And a full angle, which looks like an arc here, and you can see the angle drawn in. The full angle is what we call 360 degrees. It's exactly 360 degrees. Adjacent angles are angles that are beside each other. They share a common ray. In this case, angle BAC and angle CAD are adjacent because they have angle or ray AC in common as one of their sides. An angle bisector is a ray that cuts a big angle into 2 smaller angles that are congruent. In this case, ray BC divides angle ABD into 2 smaller angles, angle 1 and angle 2, that are both 9.73 degrees. And here you can see the proper notation to show that these 2 angles are congruent to each other, the 2 smaller angles. And you can refer to them by letters or numbers. When you are using drawings and to work with angle notation, you're going to use arcs. So you can say, like here, angle 2 and angle 3 both have 1 arc, therefore they are congruent. Whereas in this picture, angle 1 and angle 4 both have 2 arcs, so they're congruent, and angle 2 and angle 3 both have 1 arc, so they're congruent. And this picture over here, angle A and angle B both have an arc with 1 tick mark, so the number of tick marks can be used to show congruency, just like the number of arcs. So you see the difference of using the number of arcs versus number of tick marks in these 2 drawings to denote the same idea, that angle 1 and angle 4 are congruent and angle 2 and angle 3 are congruent. Perpendicular lines are lines that intersect to form 4 right angles. So if the lines form 1 right angle, 1 90-degree angle, then all 4 of those are going to be 90-degree angles. The notation for perpendicular looks like an upside down capital T. So these lines can be referred to with letters, lowercase, or they could be referred to with the points that are on them. And points are uppercase. So line J is perpendicular to line K, and you can see the notation. Line AE, using the points, is perpendicular to line DC. Again, you can see the proper notation there. Complementary angles are angles whose sum are 90 degrees. They may or may not be adjacent. In this case, we have 2 angles that are not adjacent. They do not have a common ray or common side. And then here we have 2 angles that are next to each other that add up to 90 degrees. So in either case, the 2 angles that add up to 90 degrees are considered complementary. Supplementary angles are angles that add up to 180 degrees. Again, they may or may not be adjacent to one another. So in this top example, we have two angles that are on a straight angle. So since the straight angle is split into two adjacent angles, you know the two adjacent angles have to add up to 180. Therefore, those angles are supplementary. In this example down here, we have this angle that is 105, this angle that's 75. Those two angles add up to 180, and even though they're not next to each other, they don't share a common ray, they are supplementary since they add up to 180 degrees. Vertical angles are formed whenever two lines intersect each other. So if you look at the picture above, we have two lines intersecting. Angles 1 and 2 are called vertical angles, and angles 4 and 3 are also vertical angles. So they're the angles that are across from each other whenever two lines intersect. And the lines don't need to be perpendicular, they're just intersecting one another. So when they intersect and form vertical angles, those angles will always be congruent to each other. So angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. So vertical angles are always congruent. So here's a problem where you're going to go through and figure out the degree measures of all the different angles. Given that angle BMA is 20 degrees, angle FME is 60 degrees, and angle CMD is 40 degrees. So if we look at that, we know with the vertical angles that, and I drew another picture down here to help with the colors. Angles are vertical when lines intersect. So if you look at the colors, it helps you to see which lines are intersecting. This blue one and this red one are going to create angles that are vertical from each other. So this angle that's 60 degrees will be congruent to this angle. So that one must be 60 degrees. And we also have red and green and red and green across from each other. So since this one's 40 degrees, this one over here must also be 40 degrees. So we're figuring a lot out right away. Now we have a straight angle right here, so we know it adds up to 180. All these are supplementary, adding up to 180. So since 40 and 60 is 100, plus 20 is 120, we know that this angle has to be 60. And down here, same idea. We know that 40 and 60 is 100, so this angle must be 80. Also, this big angle right here must be congruent to this angle because they both have a green and blue as their sides, so they're vertical from each other. And sure enough, 20 plus 60 does equal 80, which is the same degree measure as angle DME. Here's another example. In this case, we know that angle BHC is 20 degrees. We know that AHG is 40 degrees. And we know that GHF is 90 degrees, or a right angle. Since we know it's a right angle, we can tell that all the lines that intersect to form that one right angle, those two lines must also form other right angles. So I automatically know this is right, and this is right. So therefore, this has to be 50 degrees because these two angles are complementary. They add up to 90 degrees. This one has to be 70 degrees because these two are complementary. And then over here, I can tell that this angle and these two lines are going to intersect to form vertical angles, so this is 50. And then this angle and this angle are also vertical, so this angle is 40. And we now know the degree angles of all the different angles in this problem. Here's a word problem using complementary angles. We have two complementary angles. One of the angles has a measure that is 6 degrees greater than the other. So we have a little angle and then one that's 6 degrees greater than the other. So technically this is how you show the notation since we're dealing with degrees. Find the measures of the two angles. Well, since they're complementary, they're going to add up to equal 90 degrees. And I like to put parentheses. You don't have to, but I like to put them to make me stay clear that I have two angles and that I've included both angles in my problems. Otherwise, sometimes people forget the x and they'll just put x plus 6 equals 90. So I end up with 2x plus 6 equals 90. I'm going to add negative 6 to both sides in order to get the variable by itself. And I end up with 2x equals 84. I'm going to divide both sides by 2. And x equals 42 degrees. I'm going to plug that back in. And I find that my smaller angle is 42 degrees. And then 42 plus 6 gives me the bigger angle, which is 48 degrees. Now my check step is adding those together to make sure that they add up to 90 degrees. And sure enough, when I do that, I get 90. Another word problem, this time with supplementary. I have two supplementary angles. If the measure of one angle is 5 times the measure of the other angle, find the measure of both angles. So again, we have a big angle and a little angle. The big angle is based on the little angle. It's 5 times bigger. So I'm going to set it up like this. So I have 5x and x degrees. So we know that if we add these together, these two angles, we're going to get 180 degrees. Again, you don't have to put these in parentheses, but you can to help you visually keep up with the fact you have two angles there. So you don't forget the x, which is a common mistake. So 5x plus x is 6x. I'm going to divide both sides by 6, and x equals 30 degrees. So now I know that x is 30 degrees. So 5 times 30 is 150. And my check step is adding those together. And sure enough, this is really easy. 150 plus 30 is 180. And we know those two angles should add up to be 180 degrees since they are considered supplementary. And that's the end.